Address resolution protocol, when you send traffic to a destination host to the Ethernet network, you have to have the MAC address of that device. And the way that is resolved is through the address resolution protocol, or ARP. Now the MAC address of the device is 48-bit unique identifier, and it is embedded into a hardware while it is manufactured. The MAC address sometimes is called a physical address or a burn-in address, and we represent this in hexadecimal notation. We commonly group these with colons or dashes or periods. So an example of a MAC address is seen here. The Ethernet address of this device, which in this case is 080002001111. Again, that is hexadecimal value. Now we could have had colons between the sections, and we could have had dashes between those sections as well. They all mean the same thing. They are just represented different by different operating systems. So how does address resolution protocol work? Well, basically these machines here need the MAC address of 172.16.3.2. So in order to get it, it is going to send out a broadcast using the ARP protocol. He sends out a broadcast that say, hello, I'm looking for 172.16.3.2. Who is that? Please tell me. Now the other machine that is on the network here the broadcast, he say, okay, 172.16.3.2 is my IP. Let me reply back directly to that device that need my MAC address, and I will give him my MAC address. So this is what we see coming back here. A reply 172.16.3.2 is 0800.02001111. Now our device that is the initiating the connection can build the Ethernet frame to that he can send traffic to that device. So now that original ARP request is a broadcast, and when he sends that broadcast out, the destination is a broadcast MAC address. Now that broadcast MAC address is going to be all Fs, so it would fff.fff.fff. Now in a layer 2 header, we are also going to have a source MAC address, and that is going to be the source of device that is sending the frame out. Once ARP has done its job and created the mapping, we are going to keep in an ARP table. Now that ARP table is just table of local binding, and we can see that by issuing the ARP dash a command, and that command work on both Windows and Linux devices. And so let's take a look at an example. So before example, okay, so here is an example of the ARP dashes on a Windows device. Now of course this is a static screenshot, but we can look at this on production device. Let's go ahead and do that now. And here we pause the video and do it by yourself. Here we are on Windows device, and if we issue the ARP-A command, and immediately we see the internet address, the IP address, as well as the physical address. And this is a good example of how the physical address, which we said was another name for MAC address, can be separated by dashes. So in this case, we have 192.168.100.1, or in my case is 10.10.6.204. In your case it might be some other result. So in other example, if we have a Ubuntu or Kali server, and this device, we can issue the ARP-A and command now, and you will notice the result will be like 10.10.6.204, and then the MAC address of Ethernet card in my case is ETH0. So again, we have those three ways. We could separate it with a dot, colon, or dash, as you have seen here. There are a number of ARP attack ARP poisoning is an example of one where we try to make somebody believe that our MAC address is how you should reach a certain IP address. And so being aware of how ARP function for a security analyst is another important area that we want to make sure that we address. One thing to keep in mind with ARP is that it operates between layer 2 and layer 3 of the OSI model. And so ARP messages are going to be sent with a specific ether type, and that ether type is hexadecimal value that will be placed in the layer 2 header. It is 0x860. 800 here, and that field there lets any device at layer 2 know that the payload that is contained inside here is going to be an ARP request. Now there are other Ethernet type, for example 0x800 is IP version 4. So next